Good afternoon, guys. So today's lesson is actually going to start all of the wonderful mathy goodness that happens in Algebra 2. And the first thing we're going to talk about is what the heck is a function? Because you're going to hear me use that word a lot. Well, a function is sort of like a machine. So when I put something in, I can only get one thing out. So for example, if I want to make a Twinkie, right? Because I like Twinkies, I have to put certain ingredients in one end. Well, if I put the ingredients for a Twinkie in one end of the machine, I know I'm getting a Twinkie out the other end. In math, here's what that looks like. And it could look like a number of different things. A function could look like this, where it's an equation. And we'll talk about those. It could be a graph. So it could be something like that. Okay? It could also be something like this, where maybe I have a list of points, so like 3, 4, 5, and they map over to something else. Okay, so a function could also look like that. And that at the bottom is a number 10. That is not a W, although it kind of looks like a W. Here's what a function doesn't look like. Let's say that I draw a circle. That is not a function, and here's why. Let's say I pick a random point on the circle and I say that's the point 4, 8. Well, then this point down here would be 4 comma something else. It might be 10. So what happened there? Well, I got the same number twice. I got a 4 as an x value. So that's not a function, okay, because I can get more than one thing out when I put in x as 4. Let me think of something else. Let's say I did this. Okay, so same numbers, but now look what's happening. Now 3 is going to more than one thing. That is not a function. So a function has to have one output for every input. So those inputs can't repeat. I can't have 3 going to more than one thing. Okay? So what we're going to look at next is some different types of functions. And the one that I'm sure you're familiar with the most, and it's the most basic of all the functions, it's a little boring, is linear. So what would linear look like as a graph? Well, surprise, surprise, it's a straight line. So there's a linear function as far as a graph goes. What would it look like as an equation? Well, same example that I gave you just a minute ago. As an equation, a linear equation has no exponents. If it has an exponent, it's not linear. Okay? So there's a linear equation. What about a scenario? So a scenario that would be for a linear function would be like, let's say you bought some t-shirts and they cost you $5 each. Because they're costing you the same thing every time, that's linear. So buying t-shirts. Okay. All right. What about another type of function? What does a quadratic or a square root look like? Well, quadratics are going to be our hills and our valleys. Square root functions actually look like arrows. Okay? So for the graph, a quadratic will look like one of two things. It'll either go like this, so it'll be a valley, or it'll go like this, so it'll be a hill. What about its equation? What would the equation of a quadratic look like? Well, it's anything where my biggest exponent is 2. Now, we could have an x squared plus 4, we could have an x squared minus 5, but I've got to have the x squared. That has to be there. If it's not there, it's not a quadratic. What's a scenario for a quadratic? Let's see here. Anytime you like throw a ball up into the air or you shoot a basketball, that's an example of a quadratic. Okay, so a basketball jump shot would be an example of a quadratic. Another word you might hear me use there, the shape here of a quadratic, these are called parabolas. And that's just the name of the graph. Well, what about a square root then? What does it look like? Well, a square root looks like I just shot an arrow off into space. Okay? It can also be upside down. Just like that. So it looks like I took that parabola, so look right above it. It looks like I just took half of it and tilted it sideways. Okay? Well, what does it look like as an equation? Well, you're probably pretty familiar with what a square root symbol looks like. Looks like that right there. Okay. What about a scenario? Square root symbols we don't see a whole lot, but there are some different physics equations and stuff like that where square roots do appear. Okay. All right, our third type of function, and we can kind of group these two together, you can have a cubic or a cube root function. And here's the thing, I'd love to have fancy words to describe those to you. They look like squiggles and snakes. That's the best way I can describe them to you. And with that in mind, a cubic looks like this. Okay, it's your squiggle. A cube root, on the other hand, is your snake. It takes that cubic and tilts it sideways. Okay? What do those look like as an equation? Well, the cubic, think about if you cube something, what are you doing? You're raising it to the third power. So y equals x cubed. What about a cube root? What does that symbol look like? Okay, well, a cube root looks like a square root, but it has a little 3 on the little radical symbol, just like that. Okay, and what are some different scenarios? Well, for cubic is volume. So when you talk about like the volume of a cylinder or the volume of a box, that's what you're talking about is a cubic function. Okay, cube root, you don't see those as much, but I tell you what, if somebody finds one of those for me, okay, so if you email me an example of a cube root function in the real world, I will give you bonus points for that. Because there are some, I just don't know what it is off the top of my head. Okay, lastly, the function that we will talk about in this unit is an absolute value function. And the reason I said I'm V-basic under absolute value, so it's like I took two lines together to form a V. That's all absolute value is. So on a graph, absolute value will either be a V pointing up or it will be a V pointing down. What does it look like if I see the equation? Oh, I did not mean to do that. These little lines here around the X are called absolute value bars. And what they do is they take what's inside and make it positive. Okay, what's a scenario for absolute value? Those of you who maybe you like to build things or you work on cars, think about like when you have to put a bolt in somewhere, it has to be a certain size, right? But it could be just a tiny bit too little or a tiny bit too large and still fit the hole that that bolt has to go into. That's a scenario where you would have absolute value. Anything where I'm looking for tolerance, okay? It could be just a little bit too little or just a little bit too big, and that's okay. But if I go beyond the boundaries, now that bolt's not going to fit in the hole, okay? So for example, it's okay if a bolt is maybe 0.05 inches too long. It is not okay if that bolt is 5 inches too long, okay? So anything that deals with limits, okay, or size matters. All right, there are some other functions, but those are the ones that we are going to cover in this first unit. So happy first day of Algebra 2.